Okay, dividing monomials. If you notice the picture, the reason I chose the picture of Legos for this is because we're going to take something and we're going to break it apart into its components. And when you build something with Legos and then you take it apart, you've broken it up into its component parts. Notice that each Lego block is separate. It's not connected to any other block, right? And that's kind of what we're going to do when we divide monomials. Okay? The first thing we're going to review is what is a monomial. Does anybody remember what a monomial is? What does the word mono means one? Okay? Nomial, number or term in our definition. So we have one term things. In other words, what is a term? Okay? A term, in my definition, this is definition according to Mrs. Navickas, right? Okay. Consists of several things. A sign, a coefficient, and a variable. If you're going to have a term, you're going to have a sign and a coefficient. Those are demanded. Okay? These must have. This little guy right down here, he's an optional. Okay? If I only have the sign and the coefficient, it's called a constant term. Okay? So a constant term only has the sign and coefficient number. Okay? Examples. Okay? I'm just going to put it up just a little bit. Is that okay? All right. Examples of a constant term. Three. 3 has a sign. Even though it's not there, we understand that it's a positive 3. If we don't put a sign in front of it, it's positive. All right? 3 is a constant. It's a constant number. It does not change, and that's what the point constant means. Non-changing. Okay? Constant like God is non-changing. Okay? Doesn't change ever. These guys don't change. We can add things to them, we can subtract from them, but they don't change usually. Okay? They stay the same. However, or there's something here like -1/2. That's a constant. Okay? I haven't added any variables to it, so it's a constant. Now, the reason we use the word constant is because of that constant, it stays the same. Okay? So it might be something you write in your notes. Constants stay the same. Okay? Can I move up a little here now? Now, the variable varies. This changes. That's why it's called a variable. Okay? That changes. Now let's take some examples of variables. X. A. B. Those are examples of variables. You know that. This is kind of elementary in a way because I'm trying to remind you of what you already know. You might not have thought about it that way, but the reason we call things what we call them is because they mean something to us, okay? So when I say the constant term, you know I'm looking for a number with no variable attached to it, right? when I say the monomial, you're going to look for something that you're either going to look for a constant term or you're going to look for something that might have variables attached to it. Okay? So when I speak in this language, you'll understand what I'm talking about. Okay? Now, let's talk about the entire monomial that we normally think of. So some examples of monomials. Let's take an example. -2. Here's an example. It has no variable, but it does have a sign and a coefficient of 2. This is a constant monomial. Okay? As soon as I say 5x, I have a monomial. It's positive 5x. It's understood to be positive. Okay? That's a monomial. If I say minus 3x squared y, that is a monomial. Okay? It is composed of a sign, a coefficient of 3, which is really -3, okay? And it has a variable component part, which is a product of variables here. I have x squared and y. Now they can be to different powers. Does everybody understand what I'm saying? Okay, this is pretty basic right now so far. Okay? And I want to have time to do some properties. But we have 3 rules. Okay? All right, they're on your paper: the property of quotients, the rule for simplifying fraction, and the rule of exponents for division. 3 rules. They're right here on your paper. Okay, so don't worry about trying to get them off the projector. Okay? So if we look at these, I'm going to try to unpack these for you to show you how they really work. Let's talk about the property of quotients first. First of all, the word quotients implies division. Okay? Fractions are rational numbers and they are dividing. When you see the fraction bar, you know you're dividing. So it says if A, B, and C, A, B, C, and D are real numbers, okay, which you haven't really thought too much of, but they're real numbers, they have some certain properties, okay? Now, here's the first property that I want you to make sure that you really understand, because for some reason, even by pre-calculus, I'm still dealing with the fact that students don't get it, that I can never have a 0 on the denominator. Okay? So that means B and D cannot equal 0. And that's why you always have these things in your definition. In your definitions in your book, you always have these little things that say, if you have a fraction in this property or this definition, they'll tell you right off the bat, any variable that they put on the denominator cannot vary to be 0. It can be anything but. That means that sometimes we have restrictions on denominators. We have restrictions on variables. Okay? So in this case, what's this saying? It's saying that if I have a product, AC times BD, or AC divided by BD, I mean, okay? That's a product divided by a product. It's equal to the product of the two things. They break them up into their factors. So in other words, let's say I had 5 times 2 over 3 times 4, right? What really was this? This was 10/12. Okay? We really did this, and it was, well, that's 5 times 2 over 3 times 4. Well, that's the same thing as 5/3 times 2/4, right? I'm not going to reduce, I'm just giving you an example for something like that. That's all that's telling you. Okay? So a little bit more than that is if I had 3x over 12, I can change this to what? 3 times x over 3 times 4, right? Well, now I have 3 over 3 times x over 4, which is exactly what this property is telling me. Well, this makes it kind of neat because 3 over 3 is 1 times x over 4, and the whole thing reduces to x over 4. So what am I really doing is I'm trying to give you some methods or rules for reducing or renaming fractions to equivalent fractions. Equivalent means they're equal to each other. So this fraction, because I've done the equal sign all the way along, is equal to this fraction. It looks different, but it's equal. Okay? Now, let's go on to the next one. The next rule is for simplifying fractions. Again, we're going to simplify fractions. Fractions from now on in your life will always be in simplest terms, simplest form. So you have to know how to simplify fractions. You're really taking a fraction and giving it a new, you're just taking out something that's in there. You're pulling out the Legos that you don't need to make it as simple as possible. So in other words, just what I said, and I just did this as an example. Again, b and d cannot equal 0 because they would be on the denominator. Okay, and they're all real numbers, so for real numbers this holds true. And I just did an example like this, but I'll do another one. Okay, let's say I have 2x over 3x. Okay, let's just put the x as the variable. Now I don't know what x is, but I know x is equal to x, right? Well, this is what? 2 times x over 3 times x, right? So what is that but 2 times 3 times x over x? Well, what really happened was I canceled out. That's 1. And that's why this works up here, because I can actually just cancel out the x's. Now notice my x's here were to the same power, okay? I cannot cancel. If I had 2x squared over 3x, I have to first factor, which is what we're learning to do, the numerator and denominator. So I have 2 times x over 3 times x. Now take a look at this. I've got 3 things on the numerator and only 2 things on the denominator. Okay? What this property is telling me is I can do is if I have something on the numerator the same as something on the denominator, I can cancel them out. But notice they're all to the first power. Get everything to the first power, and now I can cancel out these 2, and I'm left with 2x over 3. Okay? So that's the rule for simplifying fractions. All right, the rules for exponents, for division. Now we've got 3 different sections here. Let's take a look at this. Now this is where you start learning something that you've probably never learned before. So here's the important part, okay? If I have something raised to a power on the numerator and something raised to a power on the denominator, and that something is the same. Notice A equals A. A equals A. Doesn't matter if it's x to the m over x to the n. The base is the same. So we're talking about same base. Remember? Okay, a to the x means a is the base. X is the exponent. Okay, everybody get this? If, now, you're not going to remember all these rules like this the way they write them, unless you're going to be a math teacher or a math professor or a nuclear scientist, okay? But you're not going to remember all these things like this the way I do. But if this numerator exponent is greater than the denominator, then I can really simplify that to being the difference of the 2 exponents in the same base. So if I have, let's say I have 5 to the 3rd over 5 to the 1st. Whoa, whoa, whoa. What happened there? 5 to the 1st. Okay, let's take a look at what this really is. This is 5 times 5 times 5, isn't it? And this is just 5. Well, just by my previous rules, what did I really have? I can cancel this out into here, right? So I really end up with 5 squared, okay? Well, what's this 2 equal to but 3 minus 1? Okay? So, if I have, let's do a more difficult one here. 2x to the 5th, y to the 7th over 3x y squared. Okay, now this is something that we're probably going to do at Algebra 2 level, but you can do it, right? Let's take a look at this. What is this really? Okay, but let's redo this one down here, okay? So I'll just change my color so you can do this, okay? This is 2, and by this rule up here, 5 is greater than the understood 1, right? So all I have to do is leave the fraction as it is because it doesn't reduce. 2/3 is in lowest terms. And on my numerator, I'm going to have x to the what? X to the 5 minus 1. Okay? Y, because y matches y, to the 7 minus 2. Okay? And I can simplify that. 2/3, and you know if I put this here, x and y, I have x to the 5 minus 1 is x to the 4th, 7 minus 2 is 5, and this becomes my simplified answer. Does everyone see that? Okay? Now, that's only in this case if your numerator exponent is greater than your denominator exponent. Now, if your numerator is greater than the denominator, we just take the reciprocal. This one just says you take the reciprocal. Okay? So let's take the same exact one. I know I'm going to run out of time here today, but let's just take the same exact problem. Let me erase some things. Whoa. Can't do more than
Shake the world.
shake the world is right. Let's get rid of some of this stuff. I should have just made a bigger eraser, right? I think you can select this stuff and just delete it, but we'll just do it this way. Okay, let's take the same fraction, 2x to the, now let's put the 1 on the top, x to the 1, right? And I'm not going to write the 1, y squared over, I'm going to leave the 3 on the denominator because I don't really care about the numbers. I'm just going to show you those. Now I'm going to put x to the 5th, y to the 7th down here. Now I have this situation right here, don't I? Where 1, my numerator, okay, is less than my denominator. So now what do I have? Leave the numbers alone, okay? Leave your numbers as 2/3. Now worry about your variables, okay? It's times. Let's just forget about the variables. Let's just worry about this part now. Because really this is talking about variables raised to a power, right? My numbers weren't raised to anything, so I could leave that. And I'm going to show you how this simplifies, okay? So x to the, it's going to be 1 over x to the what? X to the, what am I taking here? N minus m, right? That's the denominator one minus the numerator one, right? So my 5 minus my 1. Y to the 7 minus 2, right? So this is equal to 2 over 3 times 1 over x to the 4th, y to the 5th. Okay, try these on this paper for homework. You've got your homework on your list. Let's try to catch up tomorrow.
So this is homework time?
Yes, the evens, and I'll try to go over some more odds tomorrow. Sorry, we ran out of time.